share my screen. And we're hopefully going to get through these notes. Again, if you need me, stop me. If you have questions, stop me. So stem plots are another simple graphical display for fairly small data sets. Oh, sorry, wrong pen. They're also called stem and leaf plots. Stem plots give us a quick picture of the shape of a distribution while including the actual numerical values. All right. So just to make a stem plot, I'm going to explain to you how to do that. Sorry, I hope y'all have all that. The first step is to create a stem. And the second step is to put the last digit in order least to greatest. And then there's one more step, but we're going to start with this. So when we're dealing with 2-digit numbers, we're just going to put, like for 50, we'll put 5 on one side and the 0 on the other. So we have from 13, I think is the smallest one. Yes, to 57. So to make our stem, we're going to do like this. And then you have to do them in least to greatest order. So our littlest one I told you is 13, but there's quite a few of those. There's 3 of them. So 13, a 13, and a 13. We list those. Now, just like the dot plot, as I move to the 2, you want to make sure those are in line vertically. So we got the 13s. What's your next one? Is there another one with a 1 in the tens place? Yeah, the tens place.
There's a 15.
What else is there?
A 19.
19. So the 5 will go first, and then the 9, and we're done with that. So then we're going to move to the 2. So I'm going to circle all the 2s, 26, 26, 23, 24, 22, 23. What's the littlest one?
22.
22. So we're going to put a 2. There's only one of them. What'll come next?
23.
How many of them are there?
2.
I'm going to put 2 3s. And again, I'm trying to line them up together. There's a 24 and 2 26s. Then you move to their 30s. There's a 34, a 31, a 30, and a 38. So the littlest one is 30, 31, 34, and 38. Then we do our 40s. There's only one, 49. So we're done with those. And then we have 50s. We have 2 50s, a 51, and a 57. 2 50s, a 51, and a 57. Okay. Any questions on how to make that? The third thing is you have to make a key. So you literally have to write key. And you have to give an example. So like 49 represents a female student who reported having 49 pairs. And that's of shoes, but I'm not gonna write it on there because I ran out of space. So there's also males, and we're gonna make a stem and leaf plot with the males. So what's your lowest and your highest?
Your lowest is 4 and your highest is 38.
So how can I represent 4? And eventually we're gonna compare these, so we need to make sure that we can compare it. Basically, you have to have the same type of numbers. So how would we do this? What I'm saying is we're gonna put one number on this side and then the ones on this side. So how do I do like 5?
Could you put like a 0?
Yes, that's exactly what I'm getting at. So you said 4 was the smallest, 38 was the biggest. So we just need 0, 1, 2, and 3. So your single digits are what I'm going to pick up first. Your smallest one is 4. You have 3 5s. You have a 6. You have 4 7s and 1 8. Then the ones with 10s or in the teens are right here. If you look, we have 4 10s, so we need to write 4 zeros. We have an 11, we have a 12, and we have a 14. In the 2s, we just have 22, and in the 3s, we have 35 and 38. We need to make a key, and you guys know what it is, okay? 3 5 represents a male student who reported having 35 pairs of shoes. I'm not going to write that on there, but just know that you have to have a key. Okay. Any questions on making stem plots? Does everybody have this one? We're good?
Yeah.
All right. So then we have something called a back-to-back stem plot, and that's so you can compare, like the ones that we just did, you can compare males to females. So what we're going to do is you actually make 2 vertical lines. One side will be females, and the other side will be males. All right, so sometimes when we compare, it's too much data all at one time. So what I'm talking about is like this is really way too big of a leaf. So sometimes they'll cut it, okay? So they'll cut it like in half. 0 to 4 goes on one and 5 to 9 goes on the other. And what I mean by that is they write it as 2 zeros instead of just 1 0.
If you write one number like that, do you have to write all of them like
Yes,
that?
ma'am. Yes, ma'am. And again, it splits it. So if we're looking at the males, we had 1 4. So 0 to 4 is going to go on this first one, and then 5 to 9 will go on this one. So we had 1 4. We had 3 5s, 1 6, 4 7s, and an 8. The females didn't have any single digits, so you're not going to put anything on the female side. When we got to ones, again, 0 to 4 goes on the first one, 5 to 9 goes on the other one. So males had 4 10s, an 11, a 12, and a 14, but they didn't have 15, 16, 17, 18, 19. So this one is going to be blank. In the 20s, they only had 22. It goes on the first one because it's 0 to 4. They didn't have a 25. They didn't have 30 to 34, but they did have a 35. Sorry, about put that in the wrong place. And a 38. Ignore that line right there. I'm sorry I put it.
Miss Jones, I'm confused on what you're doing.
Splitting up the leaves. Now I'm putting 2 leaves per 1 digit. And so the first one, I always go, okay, so like we had 4, 5, 5, 6, 7, 7, 7, 7, 8 for the males. They
Yeah.
split like this, 0 to 4. So whatever they had 0 to 4 would go on the first 0.
Oh, okay.
And above go on the second 0. So then we,
Okay, I got
yeah, we moved to the ones and the tens digit. And then same thing, 0 to 4, but then we move here. They didn't have any 15, 16, 17, 18, 19.
Okay.
When we go to 40s and 50s, they didn't have any. The female will probably make more sense because they have more numbers, okay? They didn't have any zeros, but you got to think backwards on this, okay? Think backwards. So they had 3 13s, and this one's not really going to help you, but you're writing them backwards, okay? Least is going to go next to the stem. They had a 15 and a 19. It goes backwards. Least goes to the stem. They had a 22, a 23, a 23, and a 24. They had 2 26s. They had a 30, a 31, and a 34. They had a 38. They had a 49, so nothing 40 to 44. They had 2 50s and a 51 and a 57. It's just showing you a back-to-back stem plot. Yes. What you got?
Oh, my microphone wasn't working, so I was trying to get to work, but I also do have a question.
Okay.
Why is there, like up top where there's 2 zeros, there's the 4 on one, and then there's all the 5s, and then you also have stuff on the left?
I just answered it, but pay attention. You ready? We split it between 4s. 0 to 4 goes on one leaf, and anything 5 to 9 goes on the next leaf. So this is called a split stem plot. Sometimes they'll do this and sometimes they won't. Okay. If there's a lot of data, they will do this so that you don't have a mile long number. I know that doesn't change this much, but if you look at these 20s right here, it does change those. So they split it. 20 to 24 goes on this leaf. 25 to 29 goes on this leaf. And it's got to be even numbers like that. Okay.
Thank you. Sorry, I was looking through my settings trying to get my microphone to work, so I didn't get that part.
It's okay. I laughed about it. We're good. All right. So a few tips, I cannot read. A few tips to consider when making a stem plot. They don't work well for large data. And that's large data sets, so the amount of numbers. So guys, you wouldn't want, like if we had 100 people, we would not want to sit here and make a stem and leaf plot for 100 people. That's just absolutely ridiculous to think about. So they work well for small data, but not for large data. There's no magic number for stems. But 5 is a good minimum. So the stem part is what's in this column put together. So 5 is a good minimum. Now on the boys, we only had 4 because we only had four numbers there. Okay. If split, like we just did on the males, females that we just did, if you split it, make sure each has an equal number of possible leaf digits. So what that means is what I told you, 0 to 4 on the first one. So 0, 1, 2, 3, 4 is 5. And then 5 to 9, 5, 6, 7, 8, 9. They split it 5 to 5. Okay, so that's what it's talking about, equal number of possible leaf digits. And you can get more flexibility by rounding. And I'm gonna give you an example of that. More flexibility by rounding. An example of that, if they gave you 4, 2, 5, 4, 9, you can round that to 43,000. And then you would only have to do like 4, 3. And then your key would match. So what does that mean? If your key has to match, you would say 4, 3 represents 43,000. Okay.
Do you always want to round up?
Well, we rounded it this way to get just 2 digits like we just had. So the 5 is by the 2, so that rounds up to 43.
Oh, okay.
So if it were 42.3, we would just leave it at 42.
Do you do that often or not really? Because rounding in stats is kind of,
We don't, we don't make stem and leaf plots a lot. I think they just go over them. Now, what you will do, or what I've seen, is that you will describe like the shape and possibly find the center and the spread from the stem plot. So that's the thing that you'll have to be doing. They don't really make you create them, like after this little section.
Miss Jones, I got a question, not about this,
Okay.
but where was our homework located last night?
On the quiz thing.
Yeah. I didn't see it either.
On the quiz?
Maybe I
What do you
didn't
mean?
open it. Maybe I didn't open it. Did I open it? Did anybody else see it? It's probably my fault.
No, it's probably just me and Haley.
I saw the day 6 quiz.
Yeah,
that's
I turned
it.
it in. I got it too.
Mine in.
Yeah,
Okay.
it's just us,
Day
Haley.
6 is-
No, maybe it's just me and Rachel. It's the day 6 one. That's what it is?
Yeah.
Okay, I'll do that.
That's okay.
Maybe it's because I was looking for day 5.
That's what I was looking for was day 5. That's what tripped me up. I was like, I'm gonna sign the dumb. Okay, I'll get that turned in tonight.
No worries. All right, use the back-to-back stem plot to write a few sentences comparing the number of pairs of shoes owned by males and females. Be sure to address shape, center, spread, and outliers. So if you guys look back at yours, and I'll try to put, I can't really do it together. So look back at yours, and what do you notice? And I don't like the back-to-back one as much as I like these two separate. So what would this one be? What shape would this one be?
Right skewed.
Okay, why is it right skewed? You are correct, but why is it right skewed?
It's got a hill on the left, and then it
Yeah.
kind of tails like on the 9.
Your max is up here, like your peak is up here, and then it tails off. And even though it peaks again right here, we're looking at the overall pattern, okay? So that wouldn't be right skewed. It's really heavy on the lower end. What about the male one?
Right? Ski.
Yeah, it's the same thing. It's really heavy up here and not so much down here. So both are right skewed. Now, if you get a question like this on the test and you don't like the way it looks, you can dot plot it You can make a histogram or something like that, whatever. You can make whatever you want to see what this is. So a dot plot would really help you see like the skewness in it. All right, both are skewed right. What about centers? Remember how I showed you to find those centers, like mark them out or whatever? So what do you think is going to be the female center? So I showed you how to do lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, low, high, low, high, low, high, low, high. What is it?
26.
26. So the female is going to be approximately 26. The male, if we do that, same thing. Low, high, low, high, low, high, low, high, low, high. We get 8 and 10 as our leftovers. So what would be your center?
9.
Perfect. And I'm going to go ahead and do this. I'm going to compare them together. So you can write a sentence. I wrote this. Eventually we'll write sentences. The female is approximately at 26, which is greater than the male at 9. All right. So their shape and center. What else do I need to do?
Out or spread.
Let's do spread. So what about the female spread?
It goes from, hold on. It goes from 13 to 57.
And the male spread? Come on, guys. Male spread. Lowest to highest.
Well, it goes from 4 to 38.
Perfect. Are there any outliers? This is spread. Are there any outliers on the female?
Wait, no, never mind. I don't know.
Do you see anything that kind of sticks out? Like there's a lot of data and then there's like one all by itself? And the answer could be no. I'm just asking you if you see anything, yes or no.
I don't really think so for the females, but
What about for the male? You are correct.
35 and 38, possibly.
Does anybody disagree with that or want to add more or?
I would add 22.
Okay. What do we write to make sure that we don't screw it up?
Possible.
Yeah, they are possible. So 22 could be a possible one. We don't quite know yet how to figure that out, but we will. And then we can say that it absolutely is. But I would always just write possible outliers at 22, 35, and 38. Okay. So here's some multiple choice stuff. I don't have the STEM plot. If you have your book, check it out. It says, here's a STEM plot of the percents of residents age 65 and older in the 50 states and the District of Columbia. The stems are whole percents and the leaves are tenths of a percent. Tenths of a percent. Sorry, I'm trying to find it for you. All right. There it is. And the question's right there. It's not a secret. Okay, the low outlier is Alaska. What percent of Alaska residents are 65 or older? $65 or older. How do we figure that out?
Is it 6.8?
Yes, why?
Because they start with like the ones on the left side are the First number before the
Says,
decimal.
yeah. It says the low outlier is Alaska. So the low end is 68, but it told you that it was 6.8. So it gave you the key. So what percent of Alaska's residents are 65 or older? 6.8. So your answer is, which one is it? A, B, C, D?
B.
What?
B.
B. 6.8. So circle B. Ignoring the outlier, the shape of the distribution is?
Roughly symmetrical.
Is everybody okay with that? I definitely agree with that. It looks like one peak in the very middle. All right, and then number 4, the center of the distribution is close to? Where do you think the
Is
center
it
is?
C?
Say it again.
C?
Yes, ma'am, 12.8. Because if this is roughly symmetrical, that peak is where your center is going to be. And the only one that falls in that peak is that, like the higher end of the peak is the 12.8. Is everybody good? So C would be your answer. So let's go back over them. B is 6.8, roughly symmetric, and 12.8. So we were supposed to do all that yesterday, so now we start the new stuff. Okay, so this is where we should have started today. Quantitative variables often take many values. A graph of the distribution is clear if nearby values are grouped together. One very common graph, it should say one very common graph of quantitative variable is a histogram. I showed you guys how to make those yesterday on your calculator, and we can go back over that later, okay? Everybody good with this page?
Yeah.
There's absolutely nothing to write on this page at all, but we're going to use it to make a histogram, okay? So the first thing that you would do is to divide the data into classes of equal width. I have about 10 minutes. If it cuts off, we'll go back in. Okay. So what that means is you would do 0 to 5, 5 to 10, 10 to 15 because you're going by fives, 15 to 20. But realize this is what happens. Your calculator shows it to you. So if you forget, your calculator shows it to you. Is this category is actually 0 to less than 5. This category would be 5 to less than 10. This category would be 10 to less than 15. So that includes all those decimals up to 15 if you did it. Two is find the count, which is called the frequency. Or percents, which is relative frequency. All right, so I'm going to show you how we do it with this chart. I'm not going to do the whole thing, okay? So if you're doing the frequency, and we're going to start with 0 to 5. We look back in that big chart, that page we didn't write anything on, and we see that they're 20. So our 0 to 5 bar on our histogram would be 20 units high. So everybody got it? For our 5 to 10, I'll look back on that page we didn't write anything on, and I see that there are 13. Again, remember, this is 5 to less than 10 that we're looking at. There are 13 of them. Those are your counts. You'll keep doing that until you get to your total. To find your relative frequency, you're going to take your number or your count out of the total. There were 50 data points. which gives you 40%. And you guys know how to do that. The next one, we had a count of 13 out of 50, which is 26%. And you just keep doing this all the way down. So again, I'm not going to do all of them for you. Then you're going to draw and label your axes. I spelled that wrong. And then create your histogram. Okay, so if you were doing the frequencies, the table said it was the percent born outside of the US. And then that first one in the category 0 to 5 was a count of 20. And this was US states. So label your axes and then create your histogram. Then you would do the next one, it would be at 13. Okay. And actually these should be put together, I screwed it up. If you do relative frequency, instead of being counts, these are going to be percents. Same label, except for you're going to have relative frequency of percent born, blah, blah, blah. And then US states, same categories. 0 to 5 had 40%. 5 to 10 had 26%. And if you look, guys, they're gonna be the same shape. So it doesn't matter if you do frequencies or relative frequencies. Sometimes it's better just to do this than to try to turn it into those percents and screw it up. All right, is everybody good with this page? Okay, I'm gonna say yes. All right. So shape, center, spread. What do histograms tell us about the percent of foreign-born residents in the United States? To find out, we follow our familiar routine, describe the pattern, and look for any departures in the pattern. Okay, so they're right here. You have your 2 at the bottom. Describe the pattern and look for any departures. So what's your shape?
Right skew.
Mm-hmm. And remember, I told you they're the same shape, so you can look at either one. They're both the same graph, okay? One is just frequency and one is relative frequency. All right, what else? What else do you notice about it? What's the other thing we got to do?
It's unimodal.
One thing they add on this is most have less than 10%. And then several had much larger. I don't really like that. When we talk about shape, center, and spread, we're not really, like, that's kind of telling you where the data's at. If you said it's skewed right, you already know that it was down here. So that's all that's saying. Most have 10%, but there was some that had larger. Okay, so most of the data is here, but some of them were larger. That's all it's saying. So where's the center? What do you think? What do you think it's close to? Yeah, so it looks like it's somewhere in this area, right? So it said between 5 and 10. So you guys would agree with that. The actual is 6.1. We don't know how to find the actual yet. It's just letting you know that your guess was good.
What is is center mean or median?
It can be either one.
Isn't median just like the value in the center, but it's not the average of all them?
Yeah, right. So if you mark out what we were doing on the stem plot from greatest to least, greatest to least, greatest to least, greatest to least, that middle point is your median.
So mean would be adding them all together and then dividing like averaging.
Yes. And
Okay,
we're
so
gonna,
which one could center be?
it can be either one. That's what we're gonna
Oh,
is which
okay.
one to use when. Yeah, we'll get there. All right. So the spread is less than 5% to greater than 25%. So less than 5%. We don't know if it's 0. They're obviously not 0, but we know it's less than 5. And we know it's greater than 25 because this is on the other side of the 25. Okay. If you're looking at the table, the actual values, 1.2 to 27.2. And then your outliers, it looks like this little box right here could be an outlier. So we can say a possible at greater than 25%. And I will tell you that it's actually not one. But again, we don't know how to figure that out yet, but we will. Okay, but it's possible that it is there. So I'm going to get these two things. Hopefully it won't cut off. If it does, we'll come back to that. Be sure to use classes of the same width. And 5 classes are a good minimum. So down here at the bottom, 0, 5, 10, 15, they want 5 of those.